Advanced Higher Maths 2019, question number 15. The equations of two planes are given below. Plane 1, 2x minus 3y minus z is equal to 9. Plane 2, x plus y minus 3z is equal to 2. Part A. Verify that the line of intersection L1 of these two planes has parametric equations x equals 2 lambda plus 3, y equals lambda minus 1, z equals lambda. This is for 2 marks. You can look at these as two simultaneous equations, and as you can see, the floating variable is lambda. You could eliminate x. That would mean that 1 minus 2 times equation 2 eliminates x. 2x minus 3y minus z is equal to 9. 2x plus 2y minus 6z is equal to 4. You can take this away. 2x minus 2x, x is gone. Minus 3y minus 2y gives you minus 5y. Minus z plus 6z gives you plus 5z. And 9 minus 4 gives you 5. Z is your floating variable, so that means that minus 5y plus 5 lambda is equal to 5, which means that minus 5y is minus 5 lambda plus 5, which means that y is equal to minus 5 divided by minus 5 just gives you 1, so that is lambda. 5 divided by minus 5 gives you minus 1, so that's lambda minus 1. To find x, you sub it back into pi 2. Sub y equals lambda minus 1 and pi 2. So x plus y, which is lambda minus 1 minus 3 lambda is equal to 2. So x plus lambda minus 1 minus 3 lambda is equal to 2. X, you take the 1 to the other side. Take the 1 to the other side, that adds on to the 2 to give you a 3. So x is equal to lambda minus 3 lambda is minus 2 lambda. Take the 2 lambda, minus 2 lambda to the other side, that gives you plus 2 lambda. And taking the minus 1 over gives you plus 2 plus 1 is 3. So that is x. And z is the floating variable, so z is lambda. That's that. Now you could have also just substituted these parametric equations into pi 1, pi 2 to prove that this is the L1 is the line of intersection of pi 1, pi 2. If you put into pi 1, you put x, which is 2 times 2 lambda plus 3 plus y minus 3y minus 3 times y is y minus 1 and minus z. Z is your floating variable lambda. You work this out, that gives you 4 lambda plus 6 minus 3 minus 3 times lambda. Y is lambda minus 1. Lambda minus 1. So you'd have minus 3 lambda plus 3 minus lambda. And if you got that out, you got 4 lambda minus 4 lambda, and you're left with just the 9. So that means that is what pi 1 is. So it's equal to 9. So that means that line satisfies that equation for pi 1. Pi 2, if you do the same for pi 2, put in these parametric equations. So x plus y, so x is 2 lambda plus 3, y is lambda minus 1 plus lambda minus 1, and you got minus 3 lambda for z, and that should equal 2. And this is giving you 2 lambda plus lambda, 3 lambda, 3 lambda minus 3 lambda, lambda's gone, 3 minus 1, and that again gives you 2. So that means that these line equations satisfy plane 2. So that would have been okay. You could have done it that way. That proves that this is the line of intersection of L1 is line of intersection of pi 1 and pi 2. So you could have done it this way. A bit easier than that, just putting in, substituting those x, y, z values into the plane equations. Right, so that's that. Now, part B. Part B is let pi 3 be the plane, pi 3 be the plane, minus 2x plus 4y plus 3z equals 4. Calculate the acute angle between L1 and pi 3. L1. Okay, so L1, you already had that, so that was x is equal to 2 lambda plus 3. Y is equal to lambda minus 1. And z is lambda. The second part is for 3 marks. Part B is for 3 marks. You need your normal vector to pi 3. So the normal vector for pi 3 comes from the coefficients of x, y, z there. Normal pi 3 is minus 2, 4, 3. The direction vector of the line L1 is direction vector of the line L1 is from the coefficients of lambda and x, y, z. That is 2, 1, 1. You're looking for the angle between the line and the plane. So if you have a plane, the line is going through the plane. The angle between the line and the plane is this angle here, so call that angle theta. The angle that you're going to find is the angle between the normal to the plane. This is your normal here to the plane. And this is the angle that you're going to be finding, this angle here. So you need to, this would be 90 degrees here. So you need to take this angle away from 90 to get the required angle, which is this theta. So cos, this is what you're going to be finding, cos phi is equal to n1 dot n2 over magnitude of n1, magnitude of n2. So you're going to work out the dot product. Minus 2 times 2 is 4. 4 times 1, minus 2 times 2 is minus 4. 4 times 2 times 4 times 1 is 4. 3 times 1 is 3. That's your numerator. you need to find the magnitude of this. So that's, you're just going to square each of these and add them together. Minus 2 squared is 4, 4 squared is 16, 3 squared is 9. And for the direction vector of the line, 2 squared is 4, 1 squared is 1, 1 squared is 1. So that's giving you a 3 in the numerator. Down here you got root 29 and root 6. So that angle that you're going to find, you're going to need to do a shift cos of this. 3 over square root of 29 times 6. That is going to give you that angle there. And then you need to take that away from 90 degrees to get the angle between the line and the plane. Shift cos of 3 divided by square root of 29 times 6, close the bracket, and that's giving you 76.9 degrees. That's this angle here that you found here. That's your 76.9 degrees is here. That's 76.9. The angle you require is the theta, the angle between the line and the plane. That's going to be 90 minus 76.9, which gives you 13.1 degrees. So that's the required angle. And this is for 3 marks. This is for, that was part B. Now for C. L2 is the line perpendicular to pi 3. Part C, L2 is the line perpendicular to pi 3. Line 3. C, L2 is perpendicular to pi 3. That means that the direction vector of L2 is coming from the coefficients of x, y, z there, which is minus 2, 4, 3. And you're given a point on the line. The point is B, 1, 3, minus 2. Determine whether or not L1 and L2 intersect. So you need to work out your parametric equations here. So what you have is x, y, z is equal to the point there, 1, 3, minus 2, plus, you're using a Greek letter there, so you might as well use mu, times the direction vector of the line L2, which is minus 2, 4, 3. That then leads you to the parametric equations. X is 1 minus 2 mu, 1 minus 2 mu. Y is 3 plus 4 mu. And Z is minus 2 plus 3 mu. This is L2. You've already got L1 there. To find whether they intersect or not, you need to equate the x, y, and z coordinates. So x1, we'll just call this x1, y1, z1. This will be x2, y2, z2. So you're going to equate these. So your x coordinates, when you equate them, 2 lambda plus 3 is equal to 1 minus 2 mu. Bring everything to this side. So 2 lambda plus 2 mu is equal to minus 2. You can half this. So lambda plus mu is equal to minus 1. So that could be one equation. That's your x. Now for your y, so you got y lambda minus 1 is equal to 3 plus 4 mu. Again, bring it to this left side. So lambda minus 4 mu is equal to 4. That's your second equation. Now for your z coordinates, z parametric equation for z, so z lambda is equal to minus 2 plus 3 mu. Bring it to this side, so lambda minus 3 mu is equal to minus 2. So that's your third equation. Lambda minus 3 mu is equal to minus 2. Okay, so now you need to eliminate, you need to find value of lambda. These parameters, you need to find their values. So if you took equation 2 minus 1 eliminates lambda. Okay, so you got lambda minus 4 mu is equal to 4, and lambda plus mu is minus 1. You can take a 1 away too from the other. So what you're ending up with is minus 5 mu is equal to 5, which means that mu is minus 1. You can sub that in to find lambda, sub in equation 1 to find lambda. So lambda minus 1 is equal to minus 1. So that means that lambda is 0. Lambda is 0. Now you need to check that out in the third equation to see if this works with these. So let's see if you can get the same value for lambda and mu with this equation here. So lambda, equation 3, lambda minus 3 mu is equal to minus 2. Lambda is 0. Minus 3 times minus 1 is equal to 3, which is not equal to minus 2, which means that L1 and L2 do not intersect. L1 and L2 do not intersect. System is inconsistent. System is inconsistent. That's it. That's the solution.